Hello students, this is Jayant Mane from Finalex Academy Ratnagiri, and this is 11th lecture of Drives and Control. Now going to discuss about components of load torque. So you have studied the motor torque speed characteristics of motors, different motors. Shunt motor, which is a constant speed motor, series motor and induction motor and all that. So just like motors, loads also have their characteristics. So it is torque speed characteristic obviously. So load is nothing but opposition to the motion of the motor, isn't it? So motor has to overcome the opposition for driving the load. So there are different types of load torques experienced by the machine, by the motor, and all those load torques have to be counterbalanced by the motor. So here are very primitive or very basic load torques. Those are actually friction torques. So there are different types of frictions. So there is a viscous friction, Coulomb friction and stiction. So just to show you here, torque and speed. So it is also here, all the three friction torques are given here, but it's a bit confusing, so I'll just redraw this. So first one is viscous friction. So it is present in third quadrant also and first quadrant. Viscous friction, TV. So what this characteristic shows, this friction torque increases with speed and decreases with speed, isn't it? So for low speeds, torque value is lower. If the speed is high, then torque is also high. That means the opposition due to this type of friction increases with speed. It depends upon speed, directly proportional to speed. Therefore, it can be written here like this. Some constant into speed gives us TV. Now this constant is what? Constant of viscous friction, and it depends upon the surface, we can say, or where the, you can say, friction is occurring. So if the surface changes, then this constant changes and the viscous friction offered is different. So what will be the change? So there will be change in the slope, because it's like constant of proportionality. This B is just like constant of proportionality. Two quantities are direct proportion or indirect proportion, and this is constant of proportionality. So for one value of B it could be like this, for another value of B it could be like this. Okay, so its nature will not change, but just its position will change, its slope will change. So that is what the viscous friction, the friction which is directly proportional to speed and also changes its direction with the speed, isn't it? If speed goes to negative, third quadrant, then this also reverses. So it always opposes, means whether it is forward motion or reverse motion, it opposes. Another type of friction is Coulomb friction. So Coulomb friction can be shown like this, a constant friction. So this is torque, frictional torque with respect to speed. What is the meaning of this curve? Whether the speed is 0 or any maximum, any speed, the torque remains same, this opposition remains same, and even with respect to direction of rotation, it gets reversed. So it is a fixed amount of frictional torque or fixed amount of opposition irrespective of speed. That is called as Coulomb friction torque, Coulomb torque. Its equation is just some constant value, isn't it? T equal to some constant. That is the equation of Coulomb torque. And the third one is stiction. So as the name indicates, stiction, it is present near zero speeds, only near zero speeds. Again, it changes its direction as the direction of rotation is reversed. So this torque is present only near zero speeds, and once the speed is slightly higher than the zero, then it goes to zero. See, it is reducing like this, going to zero. Reducing in this way. I'll just redraw it. Stiction is like this, and at zero speed it is having this value, and then it reduces as speed gains. So near zero, just after zero speed, slightly after gaining this speed, this will go to zero. So that is stiction. So this type of torque is present for heavy loads. We know that some loads like electrical locomotive or electric trains requires very high starting torque. So it is due to mainly stiction present in that. Now, in the loads, some particular type of friction could be dominant and other type of frictions would be present, but they may be present in small values. But if all the three are present in some good amount, then the effective characteristic will be like this. So this is actually the characteristic of electric locomotive. So what is the meaning of this? This is a combined characteristic actually. So if we add viscous friction, just shown here, viscous friction and Coulomb's friction as well as stiction all together, see, near zero, we have to add this point as well as this point, and TV is 0. So this point must be the stiction plus the Coulomb. Then as the speed is gained, the stiction goes to 0, but viscous friction and Coulomb friction will be there. So this part is addition of viscous friction and Coulomb friction. Similarly, in negative direction, this is stiction present, and afterwards just TV plus TC is this part. So it's like the TV characteristic is getting shifted by TC, isn't it? If this is TC and this is TV, and we add them here, so at this point it is just TC, then like this. Okay, it is a resultant characteristic, we can say. So depending upon loads, if some load which is very light, no stiction present, in that case the characteristic would be just like this. Okay, just a straight line. If there is no Coulomb, only viscous friction or very small Coulomb friction, then it is like this. Higher Coulomb friction, like this. So this is how we can calculate the load torque from the frictional torques if friction is the main opposition to the motor. Now we'll see some common natures of load torques. So first is windage load. So in previous lecture also I had told you that windage is represented like this. It is an exponential curve. So because the opposition depends upon the speed square, or TL proportional to speed square, therefore the characteristic is like this. So if we remove this constant of proportionality, in that case this TL can be written as C into omega m square, where C is the constant of proportionality. This depends upon shape of the blades, and again construction of the fan, and that changes the C, so it changes the curve, shifts the curve like that, different values of C. So this is a windage type of load torque. Now second is traction load. So just now I have told you that in traction there is stiction as well as viscous and Coulomb friction all present. So due to that, the curve is just like addition of all the three, and the nature of the curve is like this. So this part is due to stiction, mainly stiction plus Coulomb friction, and this part is Coulomb friction plus viscous friction, because stiction is over after some speed. Then hoist, we have seen 4 quadrant operation of hoist in a lecture. So in that 4 quadrant operation, in hoist there is mainly the Coulomb and viscous friction present, no stiction. So therefore the characteristic is like this, and this is very interesting. This is a constant power characteristic. That means here, as speed and torque are inversely proportional, like that. When speed increases, torque reduces, and if speed reduces, torque increases. So it is like that. It is constant power torque. So their product power is torque into speed. This product almost remains constant, therefore it is called as constant power torque. So these are some popular load torques given. So example of windage is fan, compressor, all those. So this is all about the load torque.